Okay, so this walkthrough is on standard deviation, and standard deviation helps you determine the amount of variation in data values. So when you are looking at a set of data, you can tell how much variation there is in the values by looking at the standard deviation. And the point of this walkthrough is not to really fully understand what standard deviation is. The point of this walkthrough is just to teach you how to find it. So we will dive deeper into what standard deviation actually is and how you can use standard deviation to interpret the data later. But for now, I just want you to understand the steps on how to find standard deviation. So on standard deviation, you have this like really tricky looking formula, and the formula looks tricky because it has a bunch of symbols that maybe you haven't seen before. And so in this blue circle, you see the formula, and then all right here, you see what each symbol actually means. And I'm going to walk you through, I basically took this formula right here and turned it into these 4 steps. And so for us, steps are kind of easier to follow when the formula is really tricky. So we're going to take this data set and we're going to follow these 4 steps. So the first step is we're going to find the mean of the data set. And so we learned how to do that right before this walkthrough in our notes. For each number in our data set, we're going to subtract the mean and then square the result. Remember, square just means taking that number and timesing it by itself. Step 3 says, then take all those new numbers and find that mean. And step 4 says to take the square root of it. So it's a lot of weird math. Feels like you're going back and forth, but it's really just 4 steps. We're going to use some data. We're going to find the standard deviation, and then you are going to be able to use these 4 steps to work out a few problems on the back of this page. Okay, so let's just start with this data set that we have. So we have this practice problem. Calculate the standard deviation of the following test data by hand. Use a chart below to record the steps. So we have this data here of test scores, and when we are working with data, we always want to make sure that we put the data in order from least to greatest. Now, we're going to go ahead and do that now, but we're finding the mean, so it doesn't really matter. So we have 23, 29, 33, 57, 62, 75, 81, 99, 100, and 102. So that's our data in order from least to greatest. And again, we're finding the mean, so that doesn't really matter, but it's good just to get into that habit. So to find the mean, we need to add up all of these numbers. When I add them up, I get 660. Then I'm going to divide by how many values there actually are. And in this data set, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So 660 divided by 10 gives us a mean of 66. So that is our mean. So that is step 1, work out the mean. So we did that. Okay. Step 2 says for each number, subtract the mean and square the result. So we're going to write our test scores here, right down here, and we're going to subtract the mean from them. So let's write our test scores first. So I have 22, 29, 33, 57, 62, 75, 81, 99, 100, and 102. Now I'm going to take these numbers and I'm going to minus our mean, which is 66. So I have 22 minus 66, and that's going to give me negative 44. So let's do that for all of these. 29 minus 66 is negative 37. 33 minus 66 is negative 33. 57 minus 66 is negative 9. 62 minus 66 is negative 4. 75 minus 66 is 9. 81 minus 66 is 15. 99 minus 66 is 33. 100 minus 66 is 34. And 102 minus 66 is 36. Okay, so that was step 2, part 1. So step 2 says for each number, subtract the mean, which is what we just did. So we subtracted the mean. Now we are going to square the results. So let's go back up to these numbers. And we are going to square this difference that we got here. So anytime I square a negative number, I'm going to get a positive number. So if I have negative 44 squared, that's going to give me 1,936. Negative 37 squared is 1,369. And then I'm just going to write these. And you can find this out too. You could even pause the video and see if you can do it, and then check your answers and see if you get the right answers. $15 squared is 225. 33 squared is 1089. 34 squared is 1,156. And 36 squared is 1,296. Okay, so let's go back up here real fast. So step 1 says to work out the mean. We did that. We found 66 was the mean of our data. Step 2 says for each number, subtract the mean, so subtract 66 and square the result. So we did that. Step 3 says take all of those numbers now and find the mean of those numbers. So the numbers we're looking at now are all of these big numbers right here. So I have 1,936 plus 1,369 plus 1,089 plus 81 plus 16 plus 81 plus 225 and so on. And I'm going to add all of those up, and I'm going to divide by how many numbers there are, and we know that there are 10 numbers. So the sum of all of those numbers, when I add them up, is 8,338. And I'm going to divide 8,338 divided by 10, because that's how many terms there are, to find my mean, and that's 83.38. Okay, so I subtracted 66 and I got this number, and then I squared that number and I got all of these new numbers right here where these green arrows are. And then I found the mean of all of these numbers by adding them up. I added all of these, and then I divided by how many there are. So I found the mean of the new set of big numbers, and that mean is 83.38. So my final step, because we did step 3, we found the mean of the squared differences. My final step is to take the square root of what we just found. So we're going to come down here and take the square root of 83.38. So we are going to take the square root of 83.38, and we type that into our calculator, and we get 9.13. All of that work just to tell us that the standard deviation of these original test scores is 9.13. So again, we're not worried so much right now about what 9.13 means. We just want to know that we can follow the 4-step process to find the standard deviation. Maybe none of that made sense to you and you are completely lost. That's fine. This is kind of a tricky topic just because we've never seen it before and there are a lot of symbols and a lot of steps. So maybe you want to rewind the video and re-watch that and look through like what you already wrote down as I'm explaining it again, and I bet it will make sense, a lot more sense the second time. When you look at the back of your walkthrough, you have 3 data sets right now on the back that I'm asking you to find the standard deviation of. And one thing that I want you to keep in mind, and you can write this down somewhere on your paper, is that if the data set, so I'll write it up here. If the data set is close, the standard deviation will be small. So if my data set is really close, let's say I have numbers, my data set contains 1, 3, 5, 2, 4, 1, 3, 1, 1. That's my data set. So all those numbers, 1, 2, 3, 4, and 5, are all really close together. My standard deviation is going to be small because the variation in those numbers, how much they vary, is really small. So my standard deviation will be small. Likewise, if the data set is far apart or spread out, the standard deviation will be big because it's showing variance, it's showing variation. So if the numbers in my data set vary by a lot, like if I have test scores and I have some kids getting 20s and some kids getting 90s and some kids getting 100, that 20 and that 100 is pretty spread out, which means it's varying by a lot. And so my standard deviation, which shows the variation, is going to be larger than if my numbers were really close together. So when you look at these 3 data sets right here, if you notice that the numbers are pretty close together and there's not a large variation, then you can assume that your standard deviation is going to be pretty small. And if the numbers are a little bit more spread out, it's going to be a little bit bigger. So let's look at one of these examples together. Let's do this first one. Calculate the standard deviation of the following data set. Okay, so step 1 says to find the mean of all of this data set. So first I'm going to write it in order. So 7, 9, 10, 11, and 13. When I add up all of these numbers and I divide by 5, then I get a mean of 10. So when I add 7, 9, 10, 11, and 13, I get the sum of 50. When I divide by 5, because that's how many numbers are in my set, I get a mean of 10. That's step 1, find the mean. The second step is to take all of my numbers and subtract the mean. So I have the numbers 7, 9, 10, 11, and 13, and I am going to subtract this number from all of them. And so sometimes you're going to get a negative number, and that's okay because we're going to end up squaring it later. Okay, so step 1, find the mean. Step 2, subtract the mean. And part of step 2 is to take this number and square it. So I'm going to put it in parentheses and square it and figure out those new numbers of our data set. So negative 3 squared is 9. Negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 3 squared is 9. My third step now is to find the mean of those numbers. So it's find the mean, subtract the mean, find the mean again. So this time we're going to find the mean. So when I add 9 plus 1 plus 0 plus 1 plus 9, I get a sum of 20. I have to find the mean, so I'm going to divide by 5 since there are 1, 2, 3, 4, 5 numbers in my data set, and I get the number 4. And the very final step of standard deviation is to take the square root of that number. The square root of 4 is 2. So the standard deviation of this data set is 2. Okay. We notice that the standard deviation is small, and that's because there really isn't a lot of variation between these numbers. The lowest one is 7, and the highest one is 13, so there's not a huge variation, so you're not going to have a big standard deviation. So let's try this next data set. Okay, right off the bat, you should see something about this data set. All the numbers are 10, which means there is no variation. They do not vary at all. If I said, what's your favorite number? And everybody said 10, I would say, yeah, their favorite numbers didn't vary at all. They were all 10. There's no variation. So you should be guessing in your mind right now, maybe take a good guess and think, what do you think the standard deviation is if there is absolutely no variation? So let's go through this. So step 1 says find the mean. When I add up 10 plus 10 plus 10 plus 10 plus 10, I get 10, 20, 30, 40, 50 divided by 5, and that number is 10. So my mean is 10. Now I'm going to take all of my numbers, just like before, and subtract the mean. Oops, sorry. I get 0 on all of them. Now I'm going to square that new number. And again, on all of them, I get 0. The next step is to find the mean of these numbers. So if I add up 0, 0, 0, 0, and 0, I get 0. And I divide it by 1, 2, 3, 4, 5. So my mean is 0, and I take the square root. So my standard deviation on this problem is 0, which makes sense. There's no variation, so there's no standard deviation. Standard deviation shows the variation. Well, there isn't variation, so my standard deviation is 0. Okay, what I would love for you to do on this last problem is try this problem by yourself, and then when I come around to check that you did the walkthrough, I will check if you got this problem right. Maybe watch the notes again, check out the 2 examples we did together again, try this one on your own, and we will see who got this problem correct. See you in class.